Hello class, very good evening. This side Ankit Misra, and I hope I'm audible to everyone. So please confirm me once again. Hello candidates, hello Spurti, Anas, Taruna, Vijay, Sneha, Preeti. Guys, am I audible? Okay, very good to know. So how was your overall practice is going on? Just let me know. Okay, let me just share my screen. Okay, so we were like started with the logistic regression part and we have completed one project also, right? So now today onwards we'll start with the multiple linear regression, and we know that multiple logistic regression, right? Multiple classification kind of thing. Okay, so let me just open a new notebook, or I can just do one thing. Let me just open the previous one so that you can also take a reference of that. And you guys also open the same notebook, like classification problem for machine learning regress, like for machine learning. And let me just share the notebook link as well. You guys can take a reference of this. And if you're not familiar with the GitHub ID now, so let me just share my GitHub account as well. And you can just probably start with the same code as well, right? So we have completed the project, and the project was related to whether the customer will buy the insurance or not. And that was completely based on the logistic regression. It was a binary classification, right? And we know that the binary classification is some sort of very easy one where the we need to start with the logistic regression, and it's completely based on the sigmoid curve, and the formula is like something 1 upon 1 plus e raised to the power minus x. X is just nothing, it's a y is equals to mx plus c equation of line, right? So on today we are going to start the multiple linear like multiple logistic regression, and it is like kind of multiple classification or like multi-class classification. And I have already given you this data set. You have to start with this one, right? It is like a digit data set. So once I run this code, then we'll probably call this data set. If you want to do it parallelly, you can just load the same notebook. I have already shared you the link, and then we'll probably start, right? Okay, so I hope my screen is visible and I have already executed all the cell. Let me just write the basic print one, then we'll start. From sklearn.dataset, print load digits. There might be some internet issue. Let me just share, check the screen again. Guys, am I audible and my screen is visible now? Just let me know, because the cell code is not executing, right? Okay, oh, got it. Due to the like input issue, na? Let me just stop this. Perfect. Okay. Now the problem is we have a multi-class classification, and we know that what is multi-class classification? Where we have more than two classes. Generally, we refer two classes as a binary class. The first one is 1 and second one is 0, or vice versa, right? Now, what about the multi-class classification? So class, let's just start with the very basic one. Instead of this load digit, now I'll pick another data set, and that one again is very popular one. That is a load iris data set. Okay, so let's just understand what do you understand by iris. Like what exactly the iris is. If anyone is from botany field, they can just take a reference of this code to build their machine learning model. Iris is just a flower, and the flower is something like this, where we have this kind of flower, right? Where we have some there numerical features, and the features are like sepal length, sepal width, petal length, and petal width. Now let me just show you the sepal length, sepal width, petal length, and petal width as well, right? So you can just simply Google it, sepal length and petal of the iris, right? This one is referred as a sepal, and that one is a petal. This example is good one. Okay, this part generally refer this as a petal part, and that one is a sepal part. Now we have four different features of this sepal and petal. The first part is called length part, that is like something sepal length, and this is the sepal width part. And same we have with the petal length and the petal width part. Iris is a very popular flower in this machine learning field, and we have a three different classes of this iris flower. Let me just show you the three different classes as well. The first class is like called Setosa. The second is like the Virginica. Third is like the Versicolor. We have a three different species, right? Virginica, Versicolor, and the Setosa. Now, based on their numerical features, and we know that we have two numerical features. The first one is the sepal length, second one is petal length, petal width, sepal length, and sepal width. Now, based on their four numerical feature, what we want to predict, or we want to classify which flower is which one, right? If I get a data from user, suppose I get a data like petal length, petal width, sepal length, and petal width, and which class does this flower belongs to? I need to build a model where I just simply give the four numerical feature, and the model should confirm this flower belongs to this species, right? And we have three different species of the iris one, right? So let me just take a like a screenshot of this, or you can just simply copy this. Guys, if you want to repeat the same step now, you can do it, right? If anyone wants to do it this parallelly, just let me know, right? I'll just hello, yes, I'll just simply reduce my pace, right? So just go to this text option. You can simply paste the image area, right? Now the project is something. Let's just write this. Build a ML model that takes four features of iris flower, and the four features are like sepal length, sepal width, petal length, and the petal width. Okay. Based on all these features, I have to predict a class, flower class, and we have three different classes. The first one is Setosa. It's not like this is only the first one. It can be like vice versa, or like you can change the order as well, right? It's completely depends upon the data that we are getting. Okay. So just for now, let's just consider this Setosa as the first one. The second one is Versicolor, and the third one is Virginica. Now let's just call the data as well. So how to call the data? Again, you can use the sklearn module. From sklearn, inside the data set, you'll get the iris data. You can just also write the same code, load iris. Once you write LOAD, you'll get the multiple data set like load iris, load breast cancer, SVM light, digits, wine, files, diabetes, and so on, right? So now this time you have to call this load iris data, and we know that iris is just nothing, it's a flower, and we have a three different species. Okay, let me just run this. Now, since we have already imported the REST module, so there is no such requirement of calling all the modules, right? Now what you can do, this module has the enough data set to build your model, right? So you can call the load iris, and let's just store this inside the flower data. Okay, and just simply write this code, done. Once you get this done, now this flower data is nothing, it is in a dictionary format. If you run this now, you'll get something like this. And inside this, we have a multiple keys. So let's just write a keys. We know that this is stored in a dictionary format now. So once you run this dot keys, you will get the multiple keys and their corresponding values, right? So inside this flower data, we have data key value and then followed by their value. Again, we have a target key value, then their value, frame key value, then value, target names, and so on, right? Now, let's just understand what exactly this data is. For that, you can just say, go to this flower data, and inside this dictionary, you can call this DESCR, and DESCR is nothing, just a describe, right? And you have to pass this inside a print function. You just pass this inside a print function, and you are getting some sort of information about this iris data set. What is that? It has 150 of records and 50 for each three classes. Because we know that we have three different classes now. So 50 instances, it means 50 records for Setosa, 50 records for Versicolor, and 50 records for Virginica, right? Now we have four attributes, and the four attributes are like just nothing of four features. Attribute generally referred as a feature set: sepal length, sepal width, petal length, and petal width. All four are like features, and they are in centimeter. Okay, this is the unit. And now we know that we have a target class, and target class has like three different classes. So the first class is Setosa, second class is Versicolor, third class is Virginica, right? And these are just nothing the summary statistics of the numerical data set, right? And this data is very popular. Got like donor is Michael, uh, and the data was like some sort of around 1988, and you can just read about the rest information, right? So now what we can do, this is the information about this data set. Now we just want to divide data into two formats. The first is called X part, second is called the Y part. Now we know that candidate X part, we can simply call the X part using the flower data, and you can just simply write down this data word, right? Because we have this dictionary na, and inside this dictionary there is a key, and the key is like in form of data. You can call the values, and you can directly store it inside the X variable, and you can just simply run this. Okay, this one is your X data set. Since if you want to view this data set in a data frame format now, so you can do one thing. Instead of directly storing this inside a X value, you can just say let this convert this data into a data frame format. You just simply pass the X, and you know that inside a data frame a method or like a class, there's another argument that is called columns. And how to get the columns are like nothing, the sepal length, sepal width, petal length, and petal width. And if you want to get the columns now, it generally described by the feature names. Feature names are like the X column name. So let me just copy the feature names, and you can just pass it here, all the feature name. Now, if you want to store in a data frame format, now you can just simply store this in a data frame format. Is there any issue like we are getting some sort of error like this PD.data frame? Okay, let me first run this, then we'll get what is the issue, right? If there is any syntax error or something like this, it's a X flower data, it's a data, and we are getting something like index must be called with a collection of some kind of feature name was passed. Okay, it has an error of like index something. Okay, so let's just do one thing. We can simply convert this to data. Now, why we are getting this error? Let me just check candidate. We have this array, right? Okay, and this array is stored in this format. Okay, we can simply convert this to data. Why we are getting problem? Let me just check data frame. And if I just simply pass inside the data frame now, so I am getting the answer, right? Then why there is an error? You just check columns is equals to, okay. My mistake candidate. You cannot give a column name like this, right? See, feature names is like the key value. Key value of which one? Key value of the flower data. You have to give like this, right? Flower data, give a feature name of the flower data. Now you can run this and you will get the column name, right? Sepal length, sepal width, petal length, and petal width. All these data are in centimeter. Now we got to know this. These are my features, right? Guys, are you getting my point now? Where we are getting this data? Class, everyone, Spurti, Sarat, Taruna, Vijay, Vaishnavi, Preeti, and rest candidates. Let me know in case of any issue, guys. How to get this data set? We are getting this data set with the help of sklearn library or like a module, right? And this concept is just nothing. It's a like you're giving a dictionary data set and just passing the key value. The key value stored some data that generally stored in a X data, like X variable, and you're calling the columns as well, right? You can write down the column name manually as well, right? Now we have stored this data inside a data frame to get the proper column name, and we have directly stored the data inside X as well, right? Now let's just take the Y variable as well to get the like final target value. So we know that the data exactly stored in a flower data, and we have a column or like a key that, and the key is like the target. You can just simply run this y is equals to target, and we know that because we have a three different classes now, that is the reason we are getting 000 class, 111 class, and 222 class. And it is just nothing. It is like the Setosa, Versicolor, and the Virginica. Now, how to get the sequence? For that, you can just simply run this flower underscore data dot target names. And let me just check the target names. It will give you the proper information. 0 belongs to this Setosa, 1 is like Versicolor, and 2 is like Virginica. Now let's just store this inside the class, final class, or like a target class. You can also store this inside a target class, and we have a three target class. The first one is Setosa, it's like in a zero index. Second one is Versicolor, and third one is Virginica. Is that clear, candidate? Let me know any doubt in this step. Everyone, just say yes or no. Class, Are you with me? Are you getting the points? Spurti, Taruna, Anas, Vijay, Sarath. Okay, got it. Is there any question, candidates? Let me know the questions. Or is there any doubt? Okay. So now we know that we have proper X data set as well in the feature formats and the Y value as well. It's in a target format. And why we are getting 0, 1, 2? 0, 1, 2 are nothing, just a different classes. 0 belongs to Setosa, 1 is like Versicolor, and 2 is for the Virginica one. Now what to do? Since we have already converted data into X and Y data part, now it's time to directly, okay, before directly jumping to the model building partner, let's just understand, do some EDA portion. Now I'll just give you the overview of the EDA. You have to do the in-depth EDA, because we know that if we just in each class, if we just try to follow the depth EDA, so our like our each class eventually end with the EDA portion only. We have to focus on ML model building as well, right? So I'll do the basic EDA right now. Let's just call this data frame and simply check the shape. df.shape, 150 instances, 4 features. df.info, is there any missing values? No, right? We are getting all the values are like numerical in nature. df.describe, you can just simply run this and we'll get the statistical information of all sepal length, sepal width, petal length, and petal width. If you want to, you can give the 2 decimal place of round value, right? The minimum sepal length is like 4.3, maximum is 7.90. The minimum width is 2, maximum is something this. The petal length is 1, maximum is 7. And the petal width is something like this, 0.10, and the maximum is 2.5. Now, can I say that the petal width could be like, can I say I'm getting the petal width of value as a 5 centimeter? No, I cannot say that, because the maximum petal width, the data that I have and my model has trained on, is like the 2.50. So you have to be make sure whatever the data that you are giving, the machine learning is just nothing, it just try to understand the pattern, right? So you cannot just simply get the petal width like 5.0 centimeter or some sort of like 6.90 centimeter as a petal width, because your machine has never seen this kind of pattern, right? This can be the issue. Now let's just do some visualization of EDA, and for that we can do one thing. Now let's just create a scatter plot, right? Scatter plot will help you to analyze and simply decode the what exactly the data set is, right? We have 3 different classes now. Let's just understand the difference, like the correlation between sepal length and sepal width. Before directly checking the correlation, let's just simply check the complete correlation, and you can just simply check df.core. It will give you the correlation between each features. Right now, because we don't have a Y target inside a data frame, and that is the reason we are not getting the correlation with the y-axis, right? You can just simply round off this data, and we know that the negative one is the negative correlation and rest are the positive correlation. And you can just say a sepal length has a very good correlation with the 87, but this is the problem, guys. Are you getting my point? There should be no correlation between feature and feature. If you are getting the correlation between feature and feature, this is the problem for the machine learning, and there is a technical term for that, and that can be referred as a multicollinearity, right? Multicollinearity is a problem in machine learning, candidate, and this question generally asked by the interviewer, right? And very simple definition, it is nothing, just a dependency of one feature to another. What exactly we want? We just simply want the dependency of feature to the target, but right now we are getting the dependency of feature with the feature, and this is like a multicollinearity. If I change X feature, the another X feature also change, and that makes the machine learning model complex model. It can be the problem for machine learning model as well. We have to avoid this kind of multicollinearity, right? And we have a techniques for that, that is called principal component analysis, where we can reduce the multiple like n dimensional feature into 2-dimensional feature. We have a concept for that, and we generally refer this as a PCA, and PCA is defined as a principal component analysis, right? We'll cover this topic in upcoming classes, right? Principal component analysis. Perfect. It is a method or a technique to reduce. Let me just write. It is a method or a technique to reduce n dimension features to two-dimension features. Okay. Suppose you're getting thousands of columns as a features, and if you want to turn out into this two features, you can use this. Why this one is important for interview point of view? Because the interviewer generally asks, if you are getting thousands of feature, how to convert this thousand of feature into two columns only, or just say two features only. So guys, you can say we have a technique for that, which is a principal component analysis. I'll let you know what is that, but in upcoming classes, right? Not right now. Okay, so you can just simply check the correlation, and now let's just visualize the data as well. So let's just do one thing. Uh, let's just directly plot a pair plot, right? Instead of writing each visual or like showing each visual, I'm just directly plotting the pair plot. And let's just do one more thing. Create another data frame, and let me write this as a DFF, and DFF is nothing. It's a like DF copy. It's a copy of DF, and we are adding another column that is a target, and target is nothing. Target is like the y value, so that we can get the different classes as well. Okay, and it's like DFF of target. We are creating additional column in DFF, and now you can run the DFF. It's like a complete data frame. Why we are calling this or creating this? Because we want to create a pair plot, and with the help of this pair plot now, we can simply analyze our complete DFF with the value of hue. Hue helps us to visualize data based on target, and we know that we have a three target classes: Setosa, Versicolor, and Virginica, and that makes the problem as a multi-class classification problem. You can just run this, and this is the pair plot. We'll get the three different classes. The one is for Setosa, second is for Versicolor, and third is for Virginica. And here we are getting the correlation as well as the three different classes as well, right? If you want, ki, sir, let's just show the name na, instead of 0, 1, 2. Can we show the name? Yes, we can show, but we have to use another method to just give the name of that, right? And let me just add it, right? You can do one thing. Instead of this target, you can just say, let's just add a target class, and this target class is nothing, just a mapping methodology of this one. You can just say df target, and let me just apply the apply method. And this apply method, what it will do, what it will try to do, it will just write the lambda, run the lambda on a row level. Row level means each row at a time. And if we are getting the zero value, zero means nothing. We have to call the zero class, and we know that zero class is a Setosa class. So you can just index this target value. You can just say like this, go to target and call the row one. Okay. Now once you run this, you will get the target value, and this value will be stored in this one, right? So we are applying the lambda. It say was never closed, which was never closed. Let me just check DFF target. We have dot apply, and inside this apply we have applied this one. This one is perfect, right? Why we are getting error, something like this? Let me just run this. Now we are getting 0 represented as a Setosa. The 1 is like the Versicolor, and 2 is like the Virginica. Now why we are calling this? Because instead of this target, we just want a target class, so that we can simply represent as the target class instead of 0, 1, 2, right? Now let's just run this. It will take some time, and instead of 0, 1, 2, now this time it will show you the Setosa, Versicolor, and the Virginica. Now this time you're getting the perfect answer. I hope everyone is getting the answer, right? Class, is there any doubt? Instead of 0, 1, 2, we have simply converted our data into a like textual class. Well, we don't want to use this. That is the reason we have temporarily just created this DFF. There is no use of this DFF right now. Just for exploratory purpose, analysis purpose, or like visualization purpose, we have created this data frame. Now what exactly we want? We just want the correlation. Correlation of what? We want a correlation of the sepal length with the petal width, sepal width with the petal length with the petal width, and petal width with the petal width. And we know that whenever we are getting the same correlation, we'll end up with the histogram, or like the same correlation with 100%, right? So you can just simply check if there is any correlation between sepal length and the petal length. So we are getting some sort of like pattern like this. If there is any correlation between sepal length and petal width, na, this area of correlation belongs to Setosa class. You can just say if we are getting any new flower, if we are getting any new flower and their correlation, if their petal width and sepal length correlation fall under this area, so we can directly say instead without creating any ML model, we can directly say this class belongs to Setosa class, and that is the power of this scatter plot, right? You can directly say if we are getting any correlation between like petal length and sepal width, if we are getting the correlation somewhat here, so we can say that this belongs to green class, and green class is your Virginica one. Like the same way you can use it for this one, right? So this makes the visualization or like the understanding easy, and that is the reason scatter plot or like the pair plot we generally use for model building creation, right? Guys, I hope everyone is getting my point, right? Preeti, Sarath, Vaishnavi, Vijay, Taruna, Spurti, and the rest candidate, just let me know if you're getting the point. And let me know if you are not getting the point as well, right? I'll try to clear it again. Guys, okay, got it. Now let's just build the model, right? Because we have analyzed the data in just a single pair plot, and we know that if we are getting somewhat of data like this, it will belongs to Setosa class, same as it is with the Versicolor class. But if we're getting some mixed kind of pattern, then we'll try to understand the other pattern. That is the reason we have a different features right now, and we want to build the model for the same, right? Now let's just call the train test split, and we'll divide the data into X and Y part. Since we have already converted data into X and Y part, now let's just see. The best part of the machine learning is now we have a limited approach. What we have to understand, this is called the statistical ML. Statistical ML is like the machine learning, which generally based on the statistical portion, right? Where each and every code is fixed. You just need to repeat the same thing. But the problem is that you have to understand the underlying concept. That is the mathematical portion. And I'll generally insist or suggest to just more focus on the mathematical portion rather than just the theoretical code one, right? So let me just convert this to X and Y, and the test size is like the 20%, 0.2. You can call the random state as well, 42, and you know that it will convert the data into 4 different parts: X train, X underscore, X underscore train, X underscore test, Y underscore train, and Y underscore test, right? Just run this. Sometime developer also print the shape of this. Well, it is not required, but this is a part of all these steps, whatever we are performing, right? So you can also, if you have a time, you can run like this: X train shape, and the code is something like this: xtrain dot shape. Just to cross verify, if we have divided data into 80-20% now, so what is the 80% of 150? It is 120. And what is the 20% of 150? It is like 30. Okay, that is the reason we can like simply print something like this: xtrain, xtest, ytrain, and ytest. So instead of this one, let me just change this to xtest, and here as well xtest dot shape, and instead of xtrain, this is ytrain dot shape, and that one is like ytest dot shape, something like this: ytest dot shape. Okay, you can run this, and we are getting 120 by 30, 120 by 30, right? Okay, is there any problem like we are getting something? Why we are getting the ytest as shape as a 4? Okay, the problem with the expert, right? You need to convert this to the y1. Now it's perfect, right? Since we have converted data into X training and testing part, now let's just create a model, and we know that we have a logistic regression, and it's completely based upon the sigmoid function. We'll call the model, we'll try to fit, and fit is just nothing, it's a training part. What we have to give class, we have to give the X train and Y train. Now you just understand all these steps, right? These are the fixed one. Once you run this, you'll get your model will get ready, right? Now what you can do, you can just predict the next value, and for that you can just simply write this ypred just being predicted by the model. So just call your model and just simply say the predict. Now we know that because we have a 3 different class now, so you can just simply give it to xtest, and xtest will try to call the y predicted value, right? So you can just simply run the ypred as well. Now, why we are getting the 10102 like something like this? Because we have 3 different classes now. That is the reason we are getting 102. Okay, let's just compare this ypred with the ytest one, right? Ytest one is the original one. Now you can simply compare. Okay, just let me know what is the first class. This is one, and what was actually It was also 1. What is the second class? It's 0. And what was actually? It was 0. And so just check, like, are we getting the same result? 0, 0, 0, 0, 2, 2, 2, and 2, 2, 2. If we are getting the same result now, that means again we are getting the 100% accuracy. And how to check this? You can check this with the training and testing score. And let's just write this training score. If you want to check the training score, you can just simply call model.score. And inside this score, you can call xtrain and ytrain, right? This is your training score. And we are getting 97% of accuracy at training level. Now let's just copy this and create a testing score. And testing score is like something this. Testing score, model.score, instead of xtrain, you have to give the xtest. Let's just give the X test, and we are getting the 100% accuracy. Now the best part is, guys, you can, if you can change the random state now, you will get another result as well. And that is the reason we are saying machine learning, deep learning, or any sort of artificial intelligence is completely based upon the probability part. Let's just change the random state. If we change the random state, we, there might be possibility we can get the some sort of different answer, right? And here you can check. We have changed the random state. Random state changing, changes in random state means we are changing the sample, and changing the sample means we are changing the training data as well as the testing data. And if we have changed the random state, although we got some values, but this time we are getting the 98% as training accuracy and 96% as the testing accuracy. And what is try to say candidate? It try to just understand the one thing. If we change the random state now, our sample got changed, and once the sample got changed, that pattern can be changed. And model, or like ML model, generally based on the pattern, and that is the reason we are getting two different accuracy at each, like random state values, right? That is the reason the testing score is 96% and the training score was something 98%. If you want to keep the random state 42, you can keep it. This was the by default, or like this is the by default random state, right? Now let's just move with the 96 score, right? Okay, we have already created our model, but we know that now the user will not try to understand what 0, 1, 2 is. You can just pick the data, sepal length, sepal width, petal length, and petal width. Now you have to convert all those data, given data, into the prediction one. So you have to create a predict function, and before creating a predict function, let's just calculate the different score. And we know that we have a function for that. Instead of calling it with the help of confusion matrix now, we can call it with the help of like method as well. Let's just first create the confusion matrix. Confusion matrix generally take the first value as a y pred. I think it should be y test, right? See, you cannot learn this thing, right? Let me just check the documentation. What is the first value? It should be like y test, I think. Confusion matrix is the documentation. Loading, right? Okay, let me just write y test and then y pred. Y pred. And CM. CM is just your confusion matrix. Now just look at this. We already know that we should get the diagonal value, not with the rest one. If we are getting the rest one, na, it is like the false positive or like the false negative. And it say we have a problem with our model building. And we know that now we are getting 96% accuracy score. It means model is not able to perform well, or like somewhat at up to level of 96%. It's not close to 100%. Because of this result, this re we should always get 0 if the data is clean. If the like model is very basic, we'll always get the 0. If the model becomes like the complex one, it tendency not close to like always 0. We'll get some sort of values, and that makes our accuracy different, right? Why we are getting 96% accuracy? Because there is one misclassification. That is the reason. Now let's just calculate the rest score, and you know that instead of calling it manually, you can call the method, and the method is like accuracy score. We have already imported this. If you don't know where we have imported this, let me show it again. From sklearn, you have to understand this, right? From sklearn.matrices, you can call all these scores, right? The first one is accuracy score, second one is recall score, the third one is F1 score, okay, and the fourth one you can directly call as a classification report, right? So that you can completely print all the reports, right? Done. Now let's just call the accuracy score. The accuracy score will be same as the model.score. So we'll get the 96% right now. Okay, you have to pass the same y test and y pred the way you like performing in the confusion matrix. You can just simply run this. The accuracy score is same as, you can just check model.score, right? It's like a testing score, right? Now let's just check the recall score. You can copy the recall score and just pass the same y test and y pred. Okay, y test and y pred. These are the Okay, now this is a problem. Let's just understand. We know that we have to focus, we have to generally use logistic regression on a binary classification level. And this is the problem, right? It's say right now we are getting the target is like a multi-class, okay? And the by default average that we are using is the binary one. It's say if the class are like multi-class, you cannot use the binary average. You have to change it to either none, micro, macro, or weighted. Now we generally refer as a weighted average or like a average recall score. So you can just simply say average is equals to weighted, and you'll run this, and we are getting the same as, because the error was just only one or like single misclassification, we are getting the recall score as same as the accuracy score. Let's just check the f1 score as well, and might be chance we will get the same error. We can just simply pass the y test and y pred, and again we are getting the same error. You can just copy this, average is equals to weighted. If you don't want to keep the average, then you can just simply pass it as none as well, right? None is like we don't want to focus on the average portion, right? So this will give you the f1 score for each individual class. It's a it working well with the zero class, somehow it's not working well with the one class, and it close to 94% with the second class. If you use the weightage average, now let me just use the weightage one, you'll get the complete score with the weightage one of this, right? Let me just call this and copy this weighted and just simply pass here, right? And you will get the single value. Now what is that? It is just nothing. It's a value like a mean value of this. Let me just show you, right? If you just simply take a mean of this, now you will get the same value, right? Some sort of like this, not directly with this one. We are getting some sort of like 94.54, something like this, but it is like calculated with the each individual class. That makes this as a weighted one, right? Okay, you can also refer this one, right? The other score is like recall score. We have already used this. If we don't want to print or each score like this one, okay, let me just call the precision one now. Here is the precision score. You can call the precision one, right? You can import the precision score, and let's just calculate the precision as well. Precision score, and just give the same data as y test and y pred, and you'll get the error. And now let's just put this to average is equals to weighted. Okay, we are getting the 97% of the precision. It means the model is likely to calculate the classes at 97%, whatever it say, right? At the 97% of preciseness, right? Precise value, right? Now let's just directly print the classification report. And the classification report is very helpful if you don't want to calculate each score individually. You just have to give the same value, like y test and y pred. You can just simply pass the classification report, and it will definitely give you the all scores like precision, recall, f1 score, and the support value. Support value is just nothing, is the y test shape, right? You can just simply check the y test shape, and y test shape is like 30, and you can just add this one 16 plus 5 is like 21, and 21 plus 9 is the 30. So these are the supports are like the data. And it's a zero class we have 16 instances, one class we have 5 instances, and two class we have 9 instances. Since one class we have very limited instances, na, that is the reason our recall and f1 score are not up to that level, because we have like very high instances or like high number of records of zero class and then followed by the two class. That is the reason we are some sort of getting the high precision recall and f1 score. Guys, I hope everyone is getting my point, right? This is the way to build a model inside a machine learning with the if the problem is related to the binary classification or like the multi-class classification. Now the best part is you have to build a function. See, we can develop a website. I'll show you the how to develop the website as well, right? And this Iris data is very popular. I can even show you how to develop website for this. whatever the project that we have developed so far. But the thing is, it required a complete 1 hour of class, right? And I'll try to first complete all the models, whatever the models or like the ML models we have, supervised or unsupervised. And finally, we'll create the website so that you can run a loop and you can deploy all your project at once. We'll finally create a project, and in that particular project, we're not individually creating one project at once, right? We'll just simply call the multiple data, and if users select any of the sort of values like digits problem, iris problem, insurance problem, income problem, sales problem, it can predict the value. So it is like one project but multiple solution. It will require multiple hours, right, to complete that project. Okay, if we want to create individually one, we can create the same as well, right? For that, we generally require, we have different framework for that. First one is Streamlit, the very popular one. Second that you can use is the Flask. Third, you can use the Django as well, right? And we should require some knowledge of fast API as well, right? It is required if we want to deploy. These are like for local host deployment. Okay, now let's just start with the function part. To just predict the flower species, we'll create a function, and that generally it takes these sepal length, sepal width, petal length, and petal width, predict species. Instead of direct flower, let's just write this as predict species. And what it takes 4 arguments: sepal length, sepal width, petal length, and petal width, right? Instead of direct passing this as an argument, now let's just create an input, right? And it is like sepal length, SEPLEN, sepal length. Sepal length is like, just take an input in a float format and just write enter sepal length, enter sepal length. And class, what we just want to give a range. Like the sepal length should be in a given range. Like the minimum is, you can just check, the minimum value is some sort of like this. Let me just create the f string, and the minimum is like df sepal length minimum. Where's the data frame? The data frame is stored in a df format, right? So you can just say go to data frame, and we have to select the minimum sepal length na. So let's just do one thing: go to data frame and then go to sepal length. Okay, and okay, so can I do one thing now? Instead of writing it now, we have already used this approach. Now let's just use the loop approach, right? What I'll do, I'll just simply run a for loop for I in df, and we know that we have 4 column inside df. First, let me just run the I, then you will understand, right? Let me just call this predict species, and if you'll just call this function, you will get each I, like sepal length, sepal width, petal length, and petal width. Now, instead of printing this, what I'll do, I'll just try to take an input, and I'll store all the input at just flower data. Okay, not directly in a flower data or like user input. Let's just say this as a user input. Okay, so let's just run a loop, and I'll take answer as an input format, and it should be in a float format. And what I'll do, I'll just simply say in a f string enter value of I. Now we know that candidate value of I, the first I is like sepal length, and it by default pick enter value of I, and I becomes sepal length, so it will say enter value of sepal length. Guys, is that clear now? Are you getting the point now? Everyone just say this: Purti, Tejasini, Vijay, Taruna, and the rest candidate. What exactly that represent? If I just simply say enter value of I, the first I becomes the sepal length, so it will say enter value of sepal length, because this is in f string or like a format string. Okay, and second thing, I'll just want to say, let's just show the minimum and maximum range of that particular data. So instead of directly passing the code, let me just write the min of I or like max of I. Min of I is like, I know that min of I is like min of sepal length and max of sepal length. The I becomes sepal width, so that min of sepal width, max of sepal width. And this is an unpacking approach. What I'll do, I'll just simply say go to that data frame, and in that particular data frame, go to that I. I is like just nothing than column, and call two things. The first one is like minimum data, and second one is like maximum one. And I'll use the aggregation approach. Okay, instead of directly calling this now, let me just show you. Let me just break the code here. Suppose my first column name is like sample length. So what I'll do, I'll just use the aggregation function, and inside this aggregation, I can pass the two values. The first is called minimum, second is called maximum, and it will give you the two values. You can convert this two value into a values format, and you will get an array. And you know that you can pass it to the minimum value, and you can pass the rest one to the maximum one. This technique is called the unpacking technique. So I'll copy this one, and I'll pass the same as here. Instead of passing the manually column, we are just referring this as I because we are running the loop, right? Once I got this minimum I and maximum I can just say enter value of I is like sample length, and the range is like minimum minimum as min I, minimum as min I, and maximum as max I. Guys, I hope all of you are getting this point, right? Can you let me know if you're not getting this one? Class, all candidates. What is that? It will try to, okay, let's just run this first, right? Then you will understand. Once you run this now, it will say enter value of sepal length. The first I becomes sepal length, and the minimum is 4.3 and the maximum is like this. Okay, instead of this now, let's just use this icon. This like tilde. Tilde is like the range. Minimum is this and the maximum is this. I hope everyone is getting the point. Can it, is that clear now? Now let's just give some space as well here so that user can easily pass the value like this. Guys, are you getting the point now? Once you store this data inside answer, can you just let me know? Vijay, got it. Once you store this data in answer, then you can append all the data inside the user input. And why we want to append data inside user input? So that we can predict the data, right? We can predict the data and predict the final species. Now what you will do, you will just simply say user input, go to user input and append the answer. Once you append the answer, because the loop will run 4 times, so you will get the answer updated 4 times or appended 4 times. And you have to convert this to final feature, and it should be in a 2D data frame. So you can just say final input, final input is like, just pass this user input inside a list. Why we are passing this user input inside a list? This user input itself is a 1D data frame, and if you just convert this like pass this to inside this list, it will convert into 2D one or like the two-dimensional one. And why we want to convert this? Because model generally takes the 2D data. Okay, now let's just call this model dot predict, model dot predict, and inside model dot predict you have to give this data as a final input. Now once you give the final input, you have to unpack this. We know that the final answer is stored in an array format. Okay, you have to unpack this with the 0th index, right? Okay, let me first show this, then you will understand, right? Okay, you will directly return this, right? Now just run this predict species. The minimum value is 4.3, maximum is 7.9. Let's just pass the 4. Enter value of sepal width. Let's just give the 5. We are not allowed to give the 5. Let's just give the 3. The minimum is 1, maximum is 6.9. Let's just give 5.6. The minimum is 0.1, maximum is 2.5. Let's just pass the 2. And let's say the array that we are getting is a 2. And we know that the 2 is like the Virginica class, or I think Versicolor, right? So why we are unpacking this or like we are slicing this? Because the final answer that we are getting, it's in a array format, candidate. That is the reason I was just calling that in a 0th index, right? And you can just say instead of directly returning as a 0, 1, 2, we know that this is the flower class. This is the flower class. And we have the flower species. We have the flower species like this, where we can just simply give the flower species. We have stored the flower species na, somewhat, yeah, like here, a target class. Now what we can do, instead of getting like giving answer in a 0, 1, 2 format, I'll say we have a target class and target class in an array format. And if we are getting any answer 0, 1, 2, just call that index of a target class, and this one is your final answer. And you can just say instead of answer, let's just say this as a final answer, right? Final answer. and how to print the final answer directly instead of directly returning this. Let's just print this. The predicted species is the final answer. Okay, the predicted species is the final answer. And if you want to show the probability, so guys, you can show the probability as well. Let's just call the probability as PV is like the probability. And how to call the probability? You have to just simply pass the model dot predict and just call the max. A max is like the probability, and you know that you can convert this to, we have already used this, we can convert this to 100 is like the percentage. And let's just round this to 2 decimal places. Okay, we have already covered this in the last class. This is the PV is like the probability, and you can just say with probability of with with probability of PV is like the probability. Now you can just simply pass it inside the format string. Now let's just run this class. I'll get the answer. We have created one function and we'll get the final answer, right? So let's just give the first sepal length value. The sepal length value is like between 4.3 and 7.59. Let's just give the 3. Enter the value of sepal width. Let's just give the 4. It's like all in centimeter. Enter value of petal length. Let's just give it 4.5. And the petal length value as 1. And now, candidate, you are getting the predicted species is Versicolor with a probability of 100%. I think this one is correct, right? We have created a function where we just need to give the sepal length, sepal width, petal length, and petal width, and it tried to predict the species, and we are perfectly getting the species, candidate. I hope everyone is getting the same, right? I hope everyone is understanding the concept, right? Candidate, let me know in case of any issue, right? Let's just create a blank print so that we can get some space or like a new line space between the entered value and the predicted species, right? Now, if you want to show the flower as well, so let's just store the flower. We have 3 different flowers now. The first flower is like Setosa, second is Versicolor, and third is Virginica. So what you can do, just understand it carefully. We have to upload the 3 flowers, right? And each flower with their name. So let's just download the Setosa. SE or let's just do one thing. Let's just save this. Okay. And go to downloads. I'll just simply open this. I'll open this. I'll open this inside. Open with the paint, right? I'll open this with paint. And we'll convert this image into 3 different formats. The first one is Setosa. So let's just crop this. That part is Setosa part, right? Let's just cut this, paste it here, click on this crop. This is Setosa. Go to file, click on save as, click on PNG picture, and save this as a Setosa. Now again press Ctrl Z. Okay, select this area. It's like Versicolor. Control X, Control A, delete all, Control V, click on crop, go to file, click on save as PNG, Versicolor. Again hit Control Z. This one is Virginica. Crop this one. Control X, Control A, delete, Control V, crop this, and save this as Virginica. Okay. Perfect. Now what I'll do, I'll just go to my Google Colab. Okay, the problem with the Google Colab is na, if you are uploading anything na, this is like a temporary. If you are trying to build this project again, you have to upload the image again, right? Just go to this file and download or like upload your all images, Setosa, Virginica, and the Versicolor. And it will give you the warning like whatever you are uploading, it's a runtime and it will be deleted if you just close this Google notebook, right? And we know that if you are doing this with this notebook na class, you have to upload this data from your side, right? Now we have this Setosa, Virginica, and the Versicolor, right? Now what you have to do, you can just simply say whatever species that we are getting, it's like Versicolor, Virginica, or Setosa, whatever the species it is. We know that it is stored in a final answer format. What you can do, you'll use the display function, and inside this display function, let's just import one module, and we have that module with and the name of that module is called IPython. We'll import the module with the name as IPython, and once we import this IPython, we have like an image method inside this, inside the display, and the method is image. And what you have to just, you have to simply give the file name, and we know that whatever final answer we are getting, so the image name will become fstring, the final answer, and then followed by the png. You can just simply say na candidate, are you getting the point now? Whatever we'll get, guys, let me know. Taruna, Spurti, Tejaswini, rest candidate, guys, 15 plus others. Whatever we'll get like as a final answer, the final answer will be Setosa, Virginica, and the Versicolor, right? Whatever the answer that we'll get, we'll just simply use the IPython, and we can just display the image with the help of this method, and we can just show the image as well, whatever the result, right? Let me just run this first. If in case of any issue, we'll correct this, right? So the sepal length is like 3, it's like 2.5, 3.6, and 2. And we are getting the Versicolor. Now you can just see the image, candidate. Guys, we are getting the, right? A function work properly, candidate? Yes or no? Let me know any issue, right? Now just imagine we can turn out this code into a proper working like a website as well. Since we have not used the website approach right now, but we have somehow able to build the module or like a model like this where we user can give the input, and it the model will eventually predict the output, right? Now let's just try to use some other values, right? Let me increase the sepal length this time. Let's just give the sepal length as 6.5, and the sepal width has 4, the petal length has 6, and the petal width has 2. Now we are getting error virginica.png. There is no file like virginica.png. Let me just check. What is the issue? Okay, it's a like spelling mistake from my side. The spelling should be VIR, and I have used VER, GINICA. Rest one is good. Like, so you can just go to this and just rename your file VIRGINICA, Virginica. Now we'll give the same data 6.54, 6 or 2. Let me just run this 6.5, 6, 4 or 2. And now you can get, we are getting the answer, right? The predicted PC is why we are getting the Versicolor. Should be the Virginica, na? Is there an issue? Let me just run it again. 6.7, 4.3, and let me just minimize this to 1, and this one has 0.5. And we are getting the Setosa. But why we are getting the probability as 0? Should be the maximum one, but we are getting the probability as 0. Model.predict. Okay. Class, it should be predict probability. My mistake, right? It should be predict probability. This one is from my side, right? It was a mistake. If we are predicting the probability, no, we cannot predict the, like, we have to predict the probability, right? That was my mistake. Let me just run it again. 6.9, and it's like 2.5. Let's just give it 1.5 and 0 point like some sort of 0.5 like this. Okay, now we are getting Setosa, but with the probability of 56.84%. So it's a model is not something like accurate, but it is somehow similar to 56.84 of Setosa. If we want to predict other class as well, candidate, so you can just print out the, or you can just have a loop over this, over the probability, right? Predict probability, and you can just say, let me just show this, right? It is, if it is 56.4% Setosa, na, then it is like somewhat as else as well, right? So let's just copy this code model dot predict probability final input, and let's just run a for loop over this, right? Here, let's just run the for loop for j in over this one model dot predict probability. And what you'll do, you'll just simply write the print j. Guys, just give me a second, right? Just give me a second. Can you just give me a second? Okay, it was like due to some background noise, like okay. So what I was saying, you can just run a for loop over the model dot predict probability, and you can just print out the all probability. It's like just print the j. Now let's just give the data again. 3.44, 4.5. I'm just giving the dummy value like, okay, and let's just give it 2. And now we are getting the probability of all three different classes, okay? Because we are, because the probability is like 2D data frame or like two-dimensional array. So we have to pick the zero value of this, like, so let's just first flatten this. You can just say, first flatten this. You can use this flatten approach, FLATTEN. We have flattened this array. And now let's just convert this to 100% as well, and just make it round as to see. This is again a hit and trial method. Like the problem is we cannot learn all this code, right? We have to understand the code. Okay, so let's just run this function again. 3.4, select 2.5. The petal width, petal length is like somewhat 3.5, and let's just take it as 2. Now we are getting 26, 53, and 26, 20.36. Now you got to know, you can just say over this loop, this belongs to like 26 probability of something this, 53 probability of something this, and so on and so on. Okay, so instead of directly this, you can just say, we know that j is like, see, let's just use another function. We have function that is called enumerate function. Enumerate try to initialize the index, right? So we have to use this enumerate. Let's just run this enumerate enumerate function. Enumerate helps us to give the index as well, right? So you can just say this one is the index and j is the value. Okay, instead of j, let's just convert this to value, and the value is like the probability value. And we know that index is like 0, 1, 2. And why we are calling 0, 1, 2? So that we can compare it with the like the target class, right? We know that in the target, we have a target class, right? So instead of directly printing this, you can just say probability of, like this, probability PROBABILIT, yeah, probability of, just simply pass the target class, probability of the target class, and just call your index. Now target class is an array, and index is like 0, 1, 2. So it will say the probability of first flower. It's like Setosa. Setosa is something like this. And once you run this, you can give the percentage as well, right? And now let me just run this. This is the final code candidate, right? Without implementing a website, but we have created some end-to-end solution where user can predict the value. 3.4, it's like 2.5. Let me just write it as 5.6 and the same as 0.5, right? Now you can just check the predicted species is Virginica with probability of 69.78%. Probability of Setosa is what? Probability of Setosa is 0.18%. Probability of Versicolor is 30.04%. And because the probability of Virginica is high, that is the reason we are getting the final predicted species as the Virginica. I hope everyone is getting my point, right? Because logistic regression is very important one. We can predict the multi-class classification as well. But in the multi-class classification, it should not like the always perfect one. It will predict the multiple classes with different probability, and it's completely based on the mathematics, right? Once you give the any value, it will try to predict each class, but it will give you the predicted value as the final probability, whatever the maximum one, right? Now let's just do some experimentation part with this function. 3.5, 2, 1, and let me just take it as 0.1. and we are getting as Setosa. Now just see here, this flower is not even close to Virginica and the versicolor as well. Now I can just say if we are getting very less sepal width, very less petal width, and same with the petal length as well, the flower likely to go Setosa side rather than versicolor and the Virginica. Now candidate, this is the power of machine learning and the mathematics. And to just implement all these things, you cannot learn, like you cannot mug up all the things. You have to understand. You cannot like do some kind of let's just learn each and every word, let's just mug up each and every word. You cannot do this, right? You have to create some sort of understanding so that you can do some experimentation part with the Python as well and with the rest code, so that the model will be the final one, right? Okay, is there any question or doubt, candidate, related to this project? In this project, we took we took the iris flower as a like input data, where we perform some sort of analysis based on their sepal length, sepal width, petal length, and petal width. We have three different target classes like Setosa, Versicolor, and Virginica. We have created one model that was completely based on the logistic regression, right? And it just try to predict the value or like the class based on their based on their numerical features, and whatever the maximum possibility, it will try to predict that one. Not only that one, it will give the probability of each individual class, but one those those with the maximum probability will be the output of the final model, right? This is the use case of logistic regression with multi-class classification, right? Now in upcoming class, why I haven't used the digit dataset right now, because we can use it like with the different models, right? We have multiple models pending right now. Now in upcoming class or like in next class, we'll start with the very new algorithm or like very popular one, which is decision tree. And inside decision tree, we can use the digit problems as well, or like or the Setosa problem or like the iris flower problem as well, right? And then followed by the random forest model, and then we'll start with the support vector machine, and then we have a knife base. All four algorithm are very important one, and this one is again interview point of view, right? Important for interview point of view, right? And then followed by the unsupervised machine learning. Then we'll start with the ANN part or like the deep learning part. And before directly jumping to the deep learning part, we need to understand the hyperparameter tuning as well, how to like overcome with the undertrained data or like the overtrained data. We have some sort of problem with the model overfitting and the underfitting. For that, we need to use the bagging and boosting technique, and that generally referred by as a ensemble technique, right? We'll try to understand all the technique, and then followed by the ANN, CNN, and RNN, right? So we have multiple things to cover, candidate, and they are already line up, right? Now just let me know any question or doubt related to this one class. Tejaswini, Sneha, Vijay, and other candidates, guys. I hope everyone is getting the point right. Is there any question or doubt? See, the pace is high, I know, but we have to cover multiple things, right? If you are not getting the point, now just let me know, right? If I'll give you time to just practice along with the training session, so we can see, you know, that we have to achieve some output, right? Because we have multiple things to perform on day-to-day basis, right? If I'll just give you time to practice it parallelly, it will consume multiple time, and we are not even to complete this on a time period, right? So I'll just only suggest take a reference from recording, take a reference from the code notebook that already shared, and just try to understand. If and still if you are facing issue, then let me know, right? You can just let me know in the next class as well. Okay. So the Tejaswini, Taruna, Sneha, Spurti, guys, any doubt, or shall I close this session? I think enough for today, right? Just let me know in the comment section or like chat box. Candidate Vijay, Sneha, other 11 candidates, no doubt, sir. Okay. So wish you all the best. Let's just meet tomorrow. Try. Okay, sir, please share the note. This notes. Okay, you want like this code notebook, na? I have already shared all the code notebook, Neha. Right? Let me just show it again. See, this one is like the GitHub profile, which is purposely created for this. Okay, you can just go to this repository, right? You will get the MLZ skill, right? MLZ skill, na? You can click on this MLZ skill and you will get the multiple files. If you click on this file or like any of the file, you'll get, I'll upload the new one, right? And if you're not getting the new one, you can take a reference of this URL, right? Let me just share this URL with you. You can run all the codes, right? Everyone, you can copy the URL or take a reference for that. I'll upload over the GitHub as well, right? Okay, is there anything else, class? Just let me know. Shall we move on? Shall we close this session? Okay, okay. So let's just connect tomorrow. Wish you all the best, candidates. Bye-bye.